EHFrame and UC table are writable at runtime because of program-independent code, no dynamic relocations, that are applied by the loader. So actually, a lot of distributions of the JVM, some of the Java libraries still have writable EHFrame. So if you've got any kind of data writing exploit, you can overwrite that. Moving forward into the future, that's not nearly as attractive because in the last few years, GCC has fixed all of that, and the EHFrame is always loaded as read-only. So there are a lot of projects that have inspired us. We owe a debt of thanks to all of these. LFSH and the RSE project gave us this sort of general idea for the self manipulation. Grub, cheating the L, return to libc exploits, tags, low create, which is another interesting example of using an unexpected computational model. That one in the relocator. If there's one sort of general philosophical thing to take away from this, it's that no exec really doesn't mean all that much. Anytime you have a program that takes some sort of input and does some processing based on that, you have a computational model. And some computational models are more powerful than others, but anytime you can find one as powerful as this, it's essentially the same as executing code. It's a virtual machine. This is how interpreters work for languages that aren't compiled. So no exec really only buys you so much.
I would like to say a few words about Oakley.
Go ahead.
Can you So no create is an amazing piece of philosophy, if you will, that you find in exploitation. What it is an obfuscator, deobfuscator, or you might say packer, unpacker, for any payload, for any code that is performed by the ELF relocator. So the standard operation of shifting a section of code up and down and catching any absolute addresses that might be in that piece is driven by a separate ELF section called the relocation section. And those sections are married to their respective targets. So there is a text.rel, there is a data.rel, and so on and so forth. And then there is, again, an automaton that interprets the relocation section and interprets the addresses. The format of the relocation section is offset arithmetic operation to perform at that offset. Offset arithmetic operation to perform on the address at this offset. So with that automaton, does that sound like a deobfuscator to you? With that automaton, you can go through your code and patch it however you like, as long as it's one of the many arithmetic operations supported by the relocator. So there is yet another virtual machine in ELF. So how many sections in your typical Linux executable? Guess. I'll take bits. So you do read elf-a and you dump the section table, and these are semantically different pieces of code and data meant to perform some special function when setting up or tearing down the address space or linking. So how many? Do I see 1? 10. Going once? Going twice? Do I hear 11? How about 35 at the minimum? That's 35 separate pieces of code and data, semantically different pieces of code and data that get interpreted by each other in very special, intimate relationships and by other pieces of standard libraries. This is what the ELF is. The ELF is a beautifully designed beast, right? So the RSE project was actually the one that sort of woke me up to this phenomenon of software engineering. This is how far it got away from, okay, here is code, here is data, jump to the beginning of code. This is what most CS people believe happens when they start a binary. Hell no. There are at least 5 different automata driven by the data contained in the executable file that set up the address space. So I have this rant, which I deliver at more scientific conferences, because you all know this, right? If you ask, if you do a Google search, or if you do an Amazon search on any book that would describe dynamic linking in Unix, in Linux, for example, you will find like one book, John Levin, Linkers and Loaders. It's thin, it's $40, you can buy it. The author actually put the previous version, pre-edit version, online, so you don't even need to buy it. But it's just like one book, and it has maybe 30% of what you need to know. Compare that to the enormous stacks of books. I mean, there are warehouses filled with books like Become an Unleashed C++ Programmer in 21 Days. Yeah, so we should find that place and, well, I don't know, loan it or something. Becoming an Unleashed C++ Programmer is not a good thing for the world. So, another with the same rep. So, cheating the elf by the grub, that was, for a long time, the only piece of information regarding the dynamic linker operation. Same for writing a Linux virus for certain aspects of relocation. So, you know, if you're familiar with LaTeX, if you ever had to write a CS paper, this is what you should do. You should cite frac. You should find the first frac article in which the idea was discussed, such as, for example, you know, chaining frames for return-oriented programming exploit. That would be 2000, 2001, frac 58. And you should cite that. Because if you cite an academic paper that introduced the term into the scientific use, 10 years later, you have not done your prior art search. Not at all. So all of these were a great inspiration.
All right, so that all wraps it up. Slides and code will be made available. I haven't put everything up yet, but I will in the next couple of days. And this is probably mostly lost on you since there are fewer Tolkien fans here than I'm used to, but there are elves, there are dwarves, there are no orcs yet. If anyone wants to make a format for an orc, that would be amazing. And if you're interested in a little more information about this, it's mostly the relevant standards and the GC mailing list.
Yeah, we might reserve the name for the weaponized work.
So I think I ran over time, so I don't know if there's time for questions, but I'm certainly happy to talk to anyone who's interested about this later. And thank you all.